for I don't love you anymore.
Okay, we're listening to Engelbert Humperdinck. But it's time to discuss peptide bonds. Very basic to biochemistry. Getting a little bit more complicated here. But as we talked about before, this is just a very simple dehydration reaction. So let's take a look. So we have glycine and we have alanine, and we add them together and water is given off. So the carboxyl group of the amino acid, you can see, connects to the amino group of the other amino acid, and then the water is given off, and we see the formation of glycyl alanine. So important message here is that the amino acids are joined together by peptide bonds, and that the carboxyl group of one amino acid connects to the amino group of the other amino acid. And remember that peptide chains exhibit polarity. You can see that the ends are different, so the amino terminus is basic and the carboxyl terminus is acidic. So good to know this. And this reaction takes place over and over, and we should just remember the basic parts of the amino acids and how they form and how they break apart. Okay, so this continues on from the previous slide. We're looking at the folding structure of proteins, again very basic. So let's look at the primary structure here. The cell cannot use this structure, so it folds up, and it tries to stabilize by forming a secondary structure. So we see the secondary structure down here. This is the tertiary structure, and this is the quaternary structure. But in the secondary structure, we look here and we can see that the hydrogen bonds are important in holding the structure together, and the amino acid bonds here, they all help to maintain the conformation of this shape. Carbon bonds here are keeping the structure, and it's kind of like a big slinky to me, but the chemical bonds that are formed here is what helps to maintain the shape and the difference between the different portions of the protein, why the protein looks different. So let's look at the tertiary form. In the tertiary form, we're starting to see it become more complicated, and we have an outside hydrophilic portion and an inside hydrophobic portion where the hydrophobic portions are trying to escape the outside, so it's folding in on itself and it's pushed into a certain conformation. This is a monomer type of form of the protein. And here we see in the quaternary structure that the different monomers are coming together, and the many polypeptides are forming and binding together. An example you could think of, it would be tubulin, which is normally seen as a dimer, and they're usually stuck together, so it's quite easy to see how the outside is hydrophilic and the inside is protecting and is for the hydrophobic portions of the proteins. So let's think about this.